to the second experiment of the same mechanics. I told you from the listed items there are two independent experiments. The two of them are used to determine the acceleration due to gravity. First one is still the same determination of acceleration due to gravity using Hooke's law. Thank you. Using Hooke's law. The second one now is this. This is also the experiment to determine the acceleration due to gravity using simple oscillation of a meter rule. Simple oscillation of a meter rule. Now let's look at the items involved. One, we have thread 1, 2. Two of them, and look at the thread. This is one. This is the second one. The two of them standing. We have a horizontal displaced meter rule. Here is it. And for stability, we placed the mass of 100 grams at the center. You can't really notice it here, but it's there due to the diagram. This mass now will stable this meter rule so that a simple oscillation of the same movement is allowed. And that equal movement both sides is called amplitude. It's regular. So looking at the entire diagram, 1, 2 rotor stands with 2 clamps, the displaced meter rule with 2 threads, measurement of the height of this horizontal meter rule using the third rotor stand with vertically inclined meter rule. So this meter rule will determine the height of this from the ground. The height of it from the ground. So from the ground, we can now notice the height of it. So this is exactly 12 centimeters from the floor. 12 cm from the floor. They can tell you to lift it 20 centimeters from the floor. It's not even part of the experiment. It's just for movement of the, so that it will be regular. So now with this, we can take off the experiment. This is the diagram. We said adjust the meter rule and the supports so that the loops of thread are at the 5.0 and 95.0 cm marks. Look at the 5. This is this point. This is 5 cm. This is 95 cm. That's why you form this a loop so that you can easily move it. So that you can move. You locate the particular number required. So this is 95. This is 95 balanced. 5 and 95 will give you what? Will give you 90. So the length from one end to the other is 90 cm. And so for the first one, we are working on what? We are working on 90. 90. 95 minus 5 is what? 90. He said, ensure that the length of each thread is 55 cm. 55 equal. So these two are equal. If they don't want to maintain, shift in this meter rule, they will still ask you to retain this trade at 5, retain this at 95, and they will tell you to change the height, this height, gradually. That is from 90 to 80, 70, 60, 50. Is another experiment, the same experiment. Is either the distance of the meter is maintained or the height is maintained. The same thing. So now our observation, I'm going to make this observation two ways. One, if there is change in the length of the meter rule, that you have length L in cm, the same time you have the time t1, t2, t average, you still obtain the period, which is small t over 20 oscillations, all in seconds. In this case, you obtain t squared, seconds squared. This is one observation. Now, if this length of the meter rule is varied, if the meter rule, the length is varied, it means log will come in. But if the thread, height of this thread is varied, log will not come in. Is it clear? So here, for me to vary the length of this log will come in. Log L and log T. This is exactly what you obtain. This is observation 1. The same diagram, the same everything. But observation 2. Observation 2. You will discover that the length is no longer maintained, but height h. That means from the diagram now, from this diagram, this thread is written h. So if I represent the same diagram now and represent this meter rule here, so that this will be h and this also will be h, this h, and they vary this h. Hence this h is varied. It means that h now in cm, h in cm, then t1, t2, t1, t2, t average, period, and period squared. This is small t over 20 in seconds, then period squared, second squared. So if h is varied, this is the table only. But if the distance of the meter rule is varied, that's the first one. So this is 2. This observation 2. So it's either you see observation 1 or observation 2. That's the correct thing. So hence the length of the meter rule is varied. That's observation 1. It means that log will come in. Because log of this will now give you the principle. But if the height only is varied, the height of the thread is varied, it means the principle is just based on the simple harmonic motion. Simple harmonic motion, which gave us that t is equivalent to 2 pi root L over G only. So this is for the variation of the length. This is for the variation of the length. That's for the variation of the length. So this is for observation 2. So I still believe that it is going to be observation 1 or 2, any of them. So the best thing is just prepare for the first, second, and third. Then any one, see in the exam, just the same. So let us now work with this. Let's work on the observation 1. I already varied what? the distance of the meter rule, which is 1. So what I have here is for varying there, I have 90. I have 90.00. And the next one from the question, next one is what? 80.00. Next one is 80. Next is what? 75.00. Next 70. Next, that's the last one. Okay, so assuming we just add 65.00. So this is what is supposed to complete for the entire experiment. So with this now, you can simply time. And how do you time? You pick up the stopwatch. I'm timing 90 for the variation of the length of the meter rule. I'm timing 90. So I will display this. First, I'll shift this one back. And then you make sure it's at equal position. Look at the movement. That's the movement. For variation 1 and for 2 is the same movement. The only difference that for 2 you are timing height, but for 1 you are timing what? Length. Thank you. That's distance. That's the same thing. So when you go through the question, you now know exactly what you're asked to do. So let's time this. Let's time this, complete one of them. So this is display. Look at the position, not too much, because you look at the angle of projection here. That's angle of displacement here. The angle between the vertical and the where it is now. So you allow it to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So what are we talking about? Time. The same thing. So just record the time here, 29.30. Then we time again. You make sure it's the right position. You make sure you stop it and then reset your time. So you time again the same angle. You allow 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I don't know whether you noticed any variation in the movement, because it slightly moved out of the position when I was about displaying it. Look at it. So if you move it out of position, it will dance. You can see. Sometimes they may ask you to do it like this. You have this form of vibration, and you still time the vibration. It's still the same thing. That is vibration. So we look at exactly the second one. Second one is because of the nature of it is 30.15. So 30.15. Average is what? $29.7. That's 7 3. It must be 2 decimal places. 29.725 cannot be recorded here. It must be 2 decimal places. Get me the periods. One 1.48. So 1.487. Then period squared. .211. Then log of L, log of 90, 1.954. Then log of T, log of T, period, log of the period T, 0.172. That's correct. So this exactly. Then, if the height is required, it means you place this to know the height of what? The height of what? The height of the thread. Height of the thread. On this side. We simply place this to know the height of the thread. So the thread now, they'll give you the height of the thread. So, but for you to now determine from this point now up to the point of displacement, that's the height of the thread. So if you are given the height of the thread, maybe as first one as 90, or 80, 70, 60. Let's know the height here. Because when they say 90, it means you remove this and then decrease, push it down to get 90 cm. Are you following it? But now let's just know this height. So from here, from the point here, I have 65 minus 12 will give me what? 53. 53. So if I want to make it 50, if they say 50, I'll simply roll this up. Roll this up. I can just enter and mount the whole thing to give me 90, so that any length mentioned, I'll roll it. And as I roll, I check the height. Is it okay? So this one now, the same 65 minus 15 is what? So assuming that here, height is 50.00. Maybe the first one, or the second one, or third one. So what am I going to do? I am now timing the height. I'm now timing the height. So timing the height means I'll displace the same 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that is 31.25. So for this one, I'll simply record 31.25. 31.25. And then I'll repeat the same experiment. I'll stop it again for the same 50. Displace through the same angle. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this one gave me 31.20. Then average 31.22. Period of oscillation 1.562. Period squared 2.439. That's exactly. So if the height is timed, that is this. This one is length. This is if length L is timed. Observation 1. If the height is timed, observation 2. But if the time, if this observation 2 is used in the exam, it means you are expected to plot the graph of L against T squared. L against T squared. L against T squared for this. But for this, you are expected to plot log L against log T. Log L against log T to give you the same principle. Because there are 4 equations that give us the same. 1, if T is equivalent to K root L is the same as log T against log L is the same as T equals 2 pi root L over G, and for the height is the same as H, small h. Is the same as T equals 2 pi root big H minus small h over G. So these are the 4 principles that give us oscillation. These are the 4 that give us the oscillation. So for plotting of graph, just based on any of these ones. And I believe you can complete all this. That's okay. So this is exactly based on the principles. I don't know whether I have any question. T average. No. It's still the time. It is still the time. It's still the time. The reading of time. It's not an evaluation. It's still the time. I believe we are true. So can we now move over to the next experiment of question number 3? Okay.